Hello everyone, welcome to my channel Matibay. In this session, you will be learning about polynomial functions. But before that, I want you to subscribe and hit the bell button. Now let us review what is a polynomial. An algebraic expression is a polynomial if it satisfies the following conditions. No variables with positive exponents should appear in the denominator. No variable with negative exponents should appear in the numerator. For example, 2 over x plus 4. Is this a polynomial or not a polynomial class? I want you to observe. Yes, this is not a polynomial. Why? Because as you can see, there is a variable under the denominator that appear in the denominator. There is a variable that appear in the denominator. So therefore, this is not a polynomial. Another example, 9x raised to the power of negative 2. Is this a polynomial or not a polynomial? Yes, not a polynomial. Why? Because the exponent is a negative integer. Remember, no variable with negative exponents should appear in the numerator. And the last one, 8x raised to 4. Is this a polynomial or not a polynomial? Yes, this is a polynomial. The second condition, variables should not appear under radical sign. For example, square root of 2x. Yes, this is not a polynomial. Why? Because the variable x here is under the radical sign. So therefore, this is not a polynomial. Another example, the square root of 5 times x. Is this a polynomial or not a polynomial? Yes, a polynomial. Why? Because only 5 is under the radical sign, while x is not under the radical sign. So therefore, this is a polynomial. The third condition is variables should not have a fractional exponent. For example, 3x to the power of 1/2. Is this a polynomial or not a polynomial? Not a polynomial because the exponent is fraction. How about this one? 2x raised to 4. Is this a polynomial or not a polynomial? Yes, a polynomial. Why? Because the exponent is a whole number, not a fraction. So always remember that an expression is a polynomial if no variables with positive exponents should appear in the denominator, or no variable with negative exponents should appear in the numerator. Variables should not appear under radical sign, and the last one, variables should not have a fractional exponent. How does a polynomial expression differ from a polynomial function? So I have here 4 examples that you're going to observe. First one is 2x squared minus 4x plus 5. The second example, 4y plus 5y cubed minus 6y to the power of 5. Third, p of x is equal to 2x squared minus 4x plus 5. And the last is p of y is equal to 4y plus 5y cubed minus 6y to the power of 5. Now, I want you to observe these 4 examples, class. So what do you observe? How does a polynomial expression differ from a polynomial function? So, observe, class, that the 2 examples are just expressions, while the last 2 examples contain the equal sign. Notice also that the expression in numbers 1 and 2 are used to define p of x and p of y in numbers 3 and 4. Therefore, numbers 1 and 2 are what? They are polynomial expression, while 3 and 4 are polynomial functions. Okay, what is a polynomial function? A polynomial function is a function that can be expressed in the form of a polynomial. The definition can be derived from the definition of a polynomial equation. A polynomial is generally represented as p of x. The highest power of the variable of p of x is known as its degree. Degree of a polynomial function is very important as it tells us about the behavior of the function p of x when x becomes very large. The domain of a polynomial function is entire real numbers. Thus, p of x is equal to a sub n times x to the power of n plus a sub n minus 1 times x raised to the power of n minus 1 plus so on, plus a sub 1 raised to the power of x raised to the power of 1 plus a sub o, where a to the sub n is not equal to 0. A sub n is the leading coefficient, this one. A sub n times x to the power of n is the leading term, this one. A sub 0 is the constant term, it's this one, and n is the degree or the exponent. Monic polynomial function is a polynomial whose leading coefficient is 1. Zero polynomial function is a polynomial function with all numerical coefficients of the variable x equal to 0. It has no degree. Polynomial functions have special names depending on their degree. So if it is a constant function, the degree is 0. If it is a linear function, the degree is 1. If it is quadratic function, the degree is. If it is cubic function, the degree is 3. If it is quartic functions, the degree is 4. And if it is quintic function, the degree is 5. Now let us state the degree, then give the special name of the following polynomial functions. Number 1. P of x is equal to 3x to the power of 5 plus x squared minus 4x plus 5. What is the degree? The degree is 5. Why? Because the highest exponent is 5. And what is the special name? The special name is quintic. The second example is P of x is equal to 2x to the power of 4 plus 5x squared plus 2x. What is the degree? Observe what is the highest exponent. So the highest exponent is 4. So therefore the degree is 4. And the special name of this polynomial function is quartic. The third example is P of x is equal to 8. What is the degree? Since 8 is constant, therefore the degree is 0. And what is the special name? Constant. Okay. If the degree is number 4, P of x is equal to 7x squared plus x minus 9. What is the degree? So look at the exponent here. The highest exponent is 2. So therefore the degree is 2. And that is quadratic. And the last example is P of x is equal to 8x plus 3. What is the exponent of x here? 1. So therefore the degree is 1. And what is the special name if the degree is 1? That is linear term. Now let us state the degree, then give the special name of the following polynomial functions. If p of x is equal to 2x5 plus 5, state the degree, then give the special name of the following polynomial functions. If p of x is equal to 2x raised to 5 plus 5x plus 2, and q of x is equal to 2x to the power of 4 plus 4, find letter A, p of 1, letter B, p of x plus q of x, meaning we're going to add this one. Letter C, p of x minus q of x, we will subtract this one to 2x4 plus 4. Then letter D, p of x times q of x, meaning we are going to multiply. Now let us solve first the number 1. P of 1 is equal to 2x to the power of 5 plus 5x plus 2, meaning we are going to substitute the value of x here, which is 1, to the variable x. So we will substitute x by 1. So what happened? So we will replace x by 1. Here, x will replace by 1. So it becomes 2 times 1 raised to 5 plus 5 times 1 plus 2. So what are we going to do next? We will solve first those who are inside the exponent. So 1 raised to 5, that is 1. 5 times 1, that is 5. Copy lang ang 2. Then after that, we will multiply 2 times 1, 2. 5 plus 2, 7. So our answer now is 9. If you want to find the degree of 2x5 plus 5x plus 2, what is the degree? The degree is 5. And that is quintec. The special name of the degree of 5 is quintec. Now let us try to find p of x plus q of x. What we're going to do, we will just add these two examples, the p of x and q of x. So p of x is equal to 2x raised to 5 plus 5x plus 2, plus q of x is 2x plus 4. How are we going to add? So you need to remember how to add expressions. In order for you to add expression, it should be what? They are what? They have the same variables and same exponent. Okay, meaning they are same variables and same exponent. So 2x raised to 5 plus 2x raised to 4 plus 5x plus 2 plus 4. As you can see here, we cannot add 2x raised to 5 plus 2x raised to 4. Why? Because they don't have the same exponent, as well as 5x. So the only constant term, this is the only term that we're going to combine. 2 plus 4 is 6. We will just copy 2x raised to 5 plus 2x raised to 4 plus 5x plus 6. So this is now our solution. Now let us proceed to the third example, the third one. Find p of x minus q of x. So we are going to subtract. So to subtract 2x raised to 5 plus 5x plus 2 minus the quantity 2x raised to 4 plus 4. So remember class, pag once that we're going to subtract, what will happen to the sign here inside the parenthesis? It will change the sign. So 2x becomes 2x raised to 4 becomes negative, and positive 4 becomes negative also. So copy 2x raised to 5 plus 5x plus 2. So 2x4 becomes negative 2x raised to 4, and positive 4 becomes negative 4. Why? We will just multiply the minus sign to each term inside the parenthesis. That's why these two, the sign of 2x raised to 4 and 4 are all negative. So combine like terms. Since 2x raised to 5 minus 2x raised to 4 plus 5x, they are not like terms, so we will just copy. So we will only subtract 2 minus 4. And what is 2 minus 4, class? And that is negative 2. Just copy 2x raised to 5 minus 2x raised to 4 plus 5x minus 2. So this is now our answer. And then what is the degree of this polynomial function 2x raised to 5 minus 2x raised to 4 plus 5x minus 2? The degree is 5. Why? Because the highest exponent is 5. And what is the special name? This is Quentec. Yes, very good. So the fourth examples, we're going to find p of x times q of x, meaning we are going to multiply these two polynomial functions. How? Of course, we will going to apply the distributive property. So we will distribute 2x raised to 4 to each term of the trinomial. So 2x times 2x raised to 5 times 2x raised to 4, that is the first thing you're going to do. Then, second, you multiply 5x times 2x raised to 4. Yan. Then, you multiply 2 times 2x raised to 4. So, as you can see, we distribute 2x raised to 4 to each term of the trinomial. Then, we will multiply 4 to each term of the trinomial. So, 2x raised to 5 times 4. Next, we multiply 5x times 4 and 2 times 4. Kita? Okay, then after that, simplify. 2x raised to 5 times 2x raised to 4 is equal to 4x raised to 9. Then 5x times 2x raised to 4, 5 times 2, 10. X times x raised to 4, that is x raised to 5. Remember, class, in multiplication, if they are the same variable, what we're going to do with the exponent, we were just going to add. So that's why x raised to 5 times x raised to 4 is x to the power of 9. 5 times 2, 10. X times x raised to 4 is x to the power of 5. 2 times 2, 4. Then copy x to the power of 4. 2 times 4, 8. And copy the x raised to the power of 5. Then 5 times 4, that is 20x, plus 2 times 4, that is 8. Then combine like terms. Saan bang like terms dito? When we say like terms, same variable and same exponent. Yes, this one. 10x raised to 5 and 8x raised to 5 are like terms. This one, they are like terms. So therefore, we can combine these two. So 4x raised to 9, just copy. And then 10 plus 8, that is 18. And copy the common terms, x to the power of 5. Then copy 4x raised to 4 plus 20x plus 8. See to it that your final answer is in descending order, meaning the degree is from highest to lowest. That's all for this session. Don't forget to subscribe and hit the bell button.